Hello, I will be talking about the synthesis of benzoin catalyzed by a coenzyme in this video. You can watch this video with Pavia Lab Manual, page 97. The reaction we will be doing today is a benzoin condensation reaction. This is a reaction of two aromatic aldehydes, in our case two benzaldehydes, in the presence of a heterocyclic catalyst, thiamine hydrochloride, to form our benzoin product. In general, a catalyst is used to help speed up the chemical reaction or lower the temperature or pressure needed to start one. Additionally, the catalyst is not consumed during the reaction. A catalytic amount of 12 mol% is used for this reaction, which is much smaller than the stoichiometric amounts of starting material used. The previous method to synthesize benzoin included the use of sodium cyanide to help the reaction proceed. However, cyanide is poisonous, so we no longer use this method. Additionally, this method isn't applicable to aliphatic aldehydes. Let's talk about thiamine hydrochloride. Thiamine hydrochloride is the hydrochloride salt form of thiamine, which is a vitamin essential for aerobic metabolism, cell growth, transmission of nerve impulses, and acetylcholine synthesis. Thiamine hydrochloride is similar to thiamine pyrophosphate, which is a coenzyme present in all living systems. Thiamine binds to an enzyme before the enzyme is activated. The enzyme also binds to the substrate. A yellide is a compound or intermediate with positive and negative formal charges on adjacent atoms. Thiamine hydrochloride catalyst contains a yellide. Experiments with the model 3,4-dimethylthiazoam bromide have explained how thiamine catalyzed reactions work. It was found that this model thiazoam compound rapidly exchanged the C2 proton for deuterium in D2O solution. At a pH of 7, this proton was completely exchanged in seconds. This indicates that the C2 proton is more acidic than one would have expected. It is easily removed because the conjugated base is a highly stabilized yellide. Thiamine is comprised of a thiazole ring, which contains both nitrogen and sulfur atoms. This ring is the reagent portion of the coenzyme. In order for this reaction to occur, thiamine HCl must be deprotonated by hydroxide. This will form a lone pair on a carbon. The lone pair will do a nucleophilic tack at the carbonyl center of one of your benzaldehydes. The electrons from the double bond will be forced up onto the oxygen, creating a negatively charged, as seen here. Your compound will then undergo an intramolecular hydrogen transfer, which will form an alcohol group, and the negative charge will now be on this carbon. The negatively charged carbon can then perform a nucleophilic attack at the carbonyl center of your other benzaldehyde, again forcing the electrons onto the oxygen, creating a negatively charged oxygen. It will undergo another intramolecular hydrogen transfer, forcing the electrons down onto this nitrogen and creating a double bonded oxygen here. This will create your benzoin product, and also you will be left with your thiamine catalyst. The procedure this week will start by dissolving thiamine hydrochloride in water. Since it is a salt, it will dissolve easily with some swirling. This should be done in a 50 milliliter round bottom flask. 95% ethanol will be added next, and the solution is to be cooled in a water bath. Next, cooled 2 molar sodium hydroxide can be added. Then you can add your benzaldehyde along with a boiling stone. The purpose of a boiling stone is to contain trapped air bubbles as they form when the liquid is heated. You will then reflux your reaction for 60 minutes. This will be done using a heating mantle, unlike a water bath. There should be very little bubbling seen, but you should be able to see the reflux ring in your condenser. It is important to use fresh benzaldehyde. But why? So benzaldehyde can undergo an oxidation reaction and will form benzoic acid, which will react with thiamine. After reflux, you will cool your solution slowly to induce crystallization. This will be followed by vacuum filtration in a Buchner funnel, and your crystals are to be washed with cold water, as warm water will likely dissolve your product. Allow your product to dry in the Buchner funnel by continuing the use of applying vacuum to suck out any more solvent. You will then obtain your crude appearance and yield. After this, we will be doing a recrystallization using hot 95% ethanol. You'll want to use as little ethanol as possible to dissolve your product. Again, you will filter and allow your product to dry before you obtain appearance, yield, and melting point of your recrystallized product.